Alright, so we're going to go ahead and get started. So we are on Unit 5 now, Analysis of Exponential Functions. So we're going to start out today with the review of properties of exponents and use the properties of exponents to solve exponential equations by reviewing both sides of the equation as a power of the same base. So that's the section we're going to start with today. So a lot of these roles should be a review, but we are going to do some more difficult problems than you might be used to be doing with the exponents. So just as a reminder before we get started, I'm just going to have an example. Let's just say 5 to the third up here. Just as a reminder for some terminology, this is the base and exponent. So again, if they refer to the base, just the variable or number that is raised to a power. Alright, so what I'd like to do first, let's go down this left column and let's try to remember the rules for exponents, get down the general rule, and then we'll go back and do the examples. So the first one, if we have the same base, but we have a to the m power and a to the nth power and they're being multiplied, what is the rule for that? And what we're trying to do is rewriting each one as a single base raised to a power. You do, so it'd be a to the m plus n. A to the m plus n. On the second one, if you are dividing with like bases, what do you do with the exponents? Right? Subtract them, so a to the m minus n. Alright, the third one, if you have a power raised to a power, what do you do with those powers? A to the m to the n. What do I do with the m and the n? Right? Multiply. A to the m times n. Alright, I'm going to write number 4 two different ways, but what's one way you can rewrite it? If I have a to a negative exponent, what can I do with that? Go ahead. I can do 1 over a to the n, but I can also write it another way. If you think about this, this was in parentheses here, so everything was to the negative nth power. If you flip it over, what is 1 to any power? It's just going to be 1. So I can write the whole thing 1 over a all to the nth power. Because 1 to the n is just going to be n, and then I have a to the n, just like the previous example. So that can be written either way. A to the 0. What does a to the 0 equal? 1. So anything to the 0 power equals 1. Okay, lastly, number 6. This one can also be written two different ways. Does anybody know how I would rewrite a to the m over n? That m divided by n is in the power. How can I rewrite that? Maybe think of an example in your head. Think of like x to the 1/2. What would you do with that? Or x to the 1/3. How could you change that? Any guesses? Any ideas? So for this one, if you had like x to the 1/2, the 1/2 power is the same as taking a square root. If you had x to the 1/3, that's the same as taking a third root. So whatever's on the bottom, so we're going to take an nth root. It's an nth root of a to the m. Nth root of a to the m. But that can also be written as, so, or nth root of a all raised to the m power. This is m. So same meaning, just can be written two different ways. Alright, let's go ahead and try some examples then. So the first one, back up here where we're multiplying like bases, says we need to add the exponents. So for this first one, you would have the same base, 5, and you're going to have 2x minus 3 plus 5 minus 4x. So what would your final answer be? What would your final answer be? Combine like terms. Anybody? Go ahead, Marie. Negative 2x plus 2. That's your final answer. Very good. Alright, the second one. We need to subtract. But before we subtract, we just learned the rule up above. When we're multiplying, we can add. So we need to add our exponents on the top, add our exponents on the bottom, then we can subtract them. So on the top, we get 2 to the power of 4x plus 4. And on the bottom, we get 2 to the power of 3x minus 4. So what is your final answer now? Because we added them, now we need to subtract like terms. So 2 to what power? Marie? That's part of it. It's negative 4, or 4 minus negative 4. Yeah. It becomes a positive, so x plus 8. Alright, on the next one, if we have a power raised to a power, we have to multiply them. Then we have like bases multiplied together, so we have to add them eventually. So, the first step, we're going to take this 3, multiply by the x, multiply by the negative 2. So we have 2 to the 3x, and then minus 6. That is multiplied by 2 to the 2 minus 2x. Now again, use your rule from up above. These are like bases multiplied together, so I can add the exponents. When I add these exponents, what's my final answer? 3? X minus 4. Alright, let's look at the next one. This one might be a little trickier. We know it has something to deal with the negative. So how could I rewrite this? Well, the first step I want to do, this negative, right now is only with the 2. It's not with the entire power. So I'm going to rewrite this 3, and I'm going to factor out a negative. Negative 2x minus 2. Now that whole power is to the negative. See how it's out in front? So now I can apply the rule. When that negative is in front of the whole power, now I can take it to the bottom. So how would that be rewritten? Again, you could write it two different ways. Go ahead. 1 over 3, and then 2x minus 2. So you could write it like that, 1 over 3 to the 2x minus 2, or you could have 1/3 in parentheses, all to the power of 2x minus 2. I'm going to leave my answer like this. Any questions so far? Alright, let's go to number 5. So this one has multiple roles going on. We see multiplication, we see division, but on the top, this multiplication, we don't have like bases. Does anybody know a way we could make like bases? How could we maybe rewrite this so we have like bases with all of them? We already have a 2 and a 2 here. How can we change that to a 2? Any guesses? Is there any way if you have a 2 to make it into a 4? What can you do to a 2 to make a 4? Ashlyn? If you divide 4 by 2, what can you do to 2 to get 4? You can either multiply by 2 or square it. So what we're going to do is we're going to change this 4 to a 2 squared. That way we have the same base with an exponent. So it actually becomes 2 squared because we're replacing just that 4. Now the 2 squared is raised to the 2x plus 2 power. Because this 2 squared is really just taking the place of the 4, not the 4 and the exponent. So we have 2 squared to the 2x plus 2 times 2x minus 1, or 2 to the x minus 1, sorry. Thank you. All divided by 2 to the 5x plus 3. Now we have like bases, we can use all of our rules. Well, first we have a power to a power, so we need to take care of that first. This 2 can be multiplied by the 2x, the 2 can be multiplied by the 2. So we get 2 to the 4x plus 4 times 2 to the x minus 1 all over 2 to the 5x plus 3. Again, I did the power to a power first. Now I have multiplication with like bases. I can add my exponents. So I'm going to go up top here now. If I add the 4x and the x, I get 5x. 2 to the 5x. 4 minus 1, so I'm left with 3. And on the bottom I have 2 to the 5x plus 3. 2 to the 5x plus 3, 2 to the 5x plus 3. If I subtract my exponents, left with 2 to the 0. And once again, anything to the 0 power is 1. Starting to remember some of these rules. Might have been a while since we've done some of them. Alright, last example on this page. So we see we have a square root there. We have 3 to the 2x plus 2 power times 9 to the x minus 4 power. Again, we don't have like bases yet. So how can we change this 9 to make it a like base? 3 squared. So we can change this to the square root 3 to the 2x plus 2 times 3 squared, and the 3 squared is to the power of x minus 4. Again, you have like bases, but you can't do the multiplication, you can't add them yet until you do this power rule first. So we have square root 3 to the 2x plus 2 times 3 to the 2x minus 8. So 2x plus 2, 2x minus 8. Now we can add our exponents. We have like bases. Square root of 3 to the 4x minus 6 Now, you could say that we could stop here, but I'm going to show a simplification a little further. So the square root is the same as the 1/2 power, because that's the same as being 1 over 2. So really, we have 3 to the 4x minus 6, and all of that is to the 1/2 power. And then we can simplify this as a power to a power. Well, power to a power, you just multiply them. So 3 to the 2x minus 3. So this mess up here really simplified down to this, and they mean the same thing. Once you're finished copying that, go ahead and turn to the back. Alright, let's do a couple on the back together, and then I'd like you to try a couple on your own. So it says simplify each expression below using the properties of exponents. So as you notice, in a lot of them we have an x and a y, or an a and a b, but we're going to use all the rules that we've used from the first page. So again, just simplify. So this one here, we have powers to a power. So we have 3 to the 3rd power. We have x cubed to the 3rd power, which is x to the 9th. And we have y to the 5th to the 3rd power, which again you multiply them, so we have y to the 15th. So our final answer, 3 to the 3rd is 27, x to the 9th, y to the 15th, and we can't simplify that any further. Can't go any further. Those are not like terms. These bases are different. Alright, that was number 1. Let's look at number 4 now. So the one right below it. Go to number 4. The first thing we need to do, we see we have division, so we know eventually we're going to have to subtract, but we first have this power here that we need to take care of. And this power of 2 is to everything. So that's really going to be 3 squared, so 9. A squared squared, which is a to the 4th. B cubed squared, b to the 6th. Again, you're just multiplying these powers. On the bottom we get 25, a squared, and b to the 4th. Now, my like terms, I can divide and simplify my exponents. So 9 over 25 is just going to stay as 9 over 25. I have a to the 4th, so 4 minus 2, a squared in the top. B to the 6th, b to the 4th, so 6 minus 4, so I'm left with b squared in the top. Nothing left in the bottom, except the 25. Again, just subtracted the exponents from my like bases. Any questions on 1 or 4? Alright, let's go ahead and look at problem 7. So problem 7, we see we have this negative fractional exponent. Negative fractional exponent. So the trick for this one, what we're actually going to do, first off, we know it's negative. So anything that would be in the top would go to the bottom, and anything in the bottom would go to the top. So we can start by changing this to 16 a to the 4th over 25, and that's all to the positive 3/2 power. The negative exponent flips it. The negative exponent flips it. Now we can deal with the fractional exponent. So rewriting this, 3 over 2. So that 2 on the bottom signifies a square root. So really, we have the square root, 16 a to the 4th over 25. Remember, that can be written two different ways we have from the first page. So we can leave that cubed on the outside. Now in this problem, the reason we're leaving the cubed on the outside is when we take the square root of everything inside, it's going to work out really nicely. So we can see the square root of 16 is 4. Square root of a to the 4th is a squared. So 16a squared. Square root of 25 is 5. And we're left with that all to the 3rd power. Again, we just took the square root of everything underneath. 3rd powers on the outside. Now we have powers to powers. Yes, go ahead.
You took the square root of everything inside?
Correct. So I had the 3/2 power was to everything.
Yeah.
But again,
Did you have 4 then?
sorry, what was that?
Like the 16?
Oh, sorry, yes. That's what I meant to write, but I didn't. Good catch. Yes, 4a squared, sorry. Thanks for catching that. 4a squared over 20 or over 5. This is all cubed now. So now 4 to the 3rd power, 64. A squared to the 3rd power, multiply them, a to the 6th. And 5 cubed, 125. Was there anything else, Rebecca, or was that the only thing then? You're good? Okay. On any of those 3 that we just did together, do you have any questions? Alright, so on the remaining top portion, so the 1 through 8, we have a few examples left there. I'd like you to try to do some of these on your own now. So we've reviewed the roles, you have the front page, and we just did a few. Ashlyn?
Say like instead of it being 3 halves, it's like 5 over 4. Would it be
It would be considered a 4th root, whatever a 4th root would be of the numbers, okay? And if this was 2 over 3, you would leave the squared out here, and it would be the 3rd root. So like the 3rd root of 8 is 2. 2 times 2 times 2. It would be a 3rd root. But in this case, the 2 was on the bottom, so a 2 really is just a square root. If the 3's on the bottom, that's a 3rd root. 4's on the bottom, it's a 4th root. Whatever's on the bottom, that's the root that it becomes, okay? So go ahead and work on 2, 3, 5, 6, and 8. If you want to work with your partner, that's fine. As you go along, make sure you check your answers up on the board. If you have any questions at all, raise your hand. We'll talk about it. Try to figure out what was wrong. Again, with a problem like number 3, just treat your numbers 12 and 15 like any fraction that you would reduce. You just get the 4 over 5. It's the exponents that you have to subtract. So you probably got a to the negative second power, and then that can move to the bottom. You could have reduced it a couple different ways for some of these and still end up with the same result. For 5, you could have done subtraction with your exponents first, then multiplied. And Ashton, here's an example where it's a 3/2 power, so it becomes a cubed root. When you get to example 6, this is a cubed root of everything inside, so cubed root of 8, 2 times 2 times 2. Cubed root of x cubed is just x. Cubed root of 27, 3 times 3 times 3. And cubed root of y to the 6th is y squared. Another way to think of this y to the 6th, if you weren't sure how that would reduce, y cubed times y cubed. Well, y cubed, cubed root of that is just y to the first power. Y to the first power, well, y times y is then y squared. So that's another way to think about that one if you weren't sure how it reduced. Anybody have questions on 2, 4, or 2, 3, 5, or 6? We have number 8 down there. Similar to number 7, start out by flipping everything, get rid of the negative exponent. And again, it's to the 2/3 power, so that becomes a cubed root on number 8. So you take the cubed root of everything inside. So what I'd like you to do with the remaining time in class, we still have some time left. Once you're done checking these answers, if you have any questions, we'll go over them. But there's 2 problems on the bottom I'd like you to at least start. And tomorrow, that's what we're going to start going over the answers to. So start with the bottom one, see if you can find your answers, try to reduce them. They want the bottom ones to be of a single base to an exponent, so like we were doing, just a little more difficult. So if you do finish with the top ones, start the bottom ones, give it a try. Tomorrow, that's what we're going to start with though. So I'll leave these ones up on the board here for you to look at. You can check your answers.